We have learned about parallel lines. We have also learned that when a transversal intersects two parallel lines, 8 angles are formed. We have learned the special names of those 8 angles and the relation between those angles. Now parallel lines are everywhere. They are all around us. They are on the desk at which you are sitting. They are on the windows. They are on the screen at which you are looking right now. So they can be observed all around us. Now you go to a carpenter and ask him to make 2 tables for you. So what he gives you is these 2 tables. Now you need to check whether these tables have parallel lines or not. So how do we check? Let us see. We have learned that if 2 parallel lines are cut by a transversal, then each pair of corresponding angles is equal in measure. So if 2 parallel lines are cut by a transversal, then each pair of corresponding angles is equal in measure. But we do not know whether these lines are parallel or not. We need to check that. So for checking that, we apply the converse of this. The converse of this says that if 2 lines, by 2 lines, we mean that any 2 lines. We do not know whether they are parallel or not. So if 2 lines are cut by a transversal such that a pair of corresponding angles is equal, then we can say that the lines are parallel. So we consider this line and this line. We consider these 2 lines of this table. We take a transversal. Now what are the corresponding angles? This and this are corresponding angles. We check whether these 2 angles are equal or not. If these angles are equal, then we can say that this line is parallel to this line. Similarly, for this table, we consider these 2 lines, this and this line. We draw a transversal. Now, this angle and this angle are corresponding angles. We measure these 2 angles. If they are equal, then these 2 lines will be parallel. If they are not equal, then these 2 lines will not be parallel. So this is what this states. If 2 lines are cut by a transversal such that a pair of corresponding angles is equal, then the lines are parallel. So let us measure these angles now and see whether the tables which the carpenter gave you have parallel lines or not. So we take a protractor. And first let's measure this angle. So I keep the center of the protractor on the vertex of the angle. The 0 line coincides with this arm. We see that the other arm corresponds to 85 degrees. So we can say that this angle is 85 degrees. So this angle is 85 degrees. Now let's measure this angle. So take the protractor, bring it to the vertex. We need to match the center with the vertex. This arm coincides with the 0. The other arm coincides with the 85 degree mark. So we can see that this angle is also 85 degree. Even this angle is 85 degree. So we see that these 2 angles, which are corresponding angles, are equal. Hence we can say that this line is parallel to this line. Now let us come to this table. So we measure this angle. We measure this angle. We see that this corresponds to 85 degrees. Hence, this angle is equal to 85 degrees. This angle is 85 degrees. Now, let's measure the other corresponding angle. So, take the protractor, place it on the center. Now, this arm should coincide with the 0 degree. It should lie on the straight line, but it doesn't. So, we need to tilt it. So, let's make it straight. We see that this angle is 85, 86, 87 degree. It coincides with the 87 degree mark on the protractor. So we can say that this angle is 87 degree. So we see that these two angles are not equal. That is, in these two lines, the corresponding angles are not equal. Hence, these two are not parallel lines. So, these two lines are parallel because the corresponding angles are equal. These two lines are not equal because the corresponding angles are not equal. So, this is called a condition for parallelism. If two lines are cut by a transversal such that a pair of corresponding angles is equal, then the lines are parallel. So this condition is a condition for parallelism because if it is satisfied, then we can say that the lines are parallel. Now we have also learned that if two parallel lines are cut by a transversal, then each pair of alternate interior angles is equal in measure, and the converse of this also holds true. That is, if two lines, that is any two lines, are cut by a transversal such that a pair of alternate interior angles is equal, then we can say that the lines are parallel. So we consider these two lines. So these are any two lines. Now if they are cut by a transversal such that a pair of alternate interior angles is equal. So let's mark the alternate interior angles. If these are equal, then we can say that these two lines are parallel. Similarly, if we consider this line and this line, we intersect them with a transversal. We mark out the alternate interior angles. Now, if these two angles are equal, then we can say that these two lines are parallel. So, we need to check for alternate interior angles in both the cases. Now, on measuring these with a protractor, it was found that this angle is equal to 85 degrees. This angle is equal to 85 degrees. This angle is 85 degrees, but this angle was 87 degrees. So this is what we have. So we can see that in this case, the alternate interior angles are equal. So we can say that these lines are parallel. In this case, the alternate interior angles are not equal. So these lines are not parallel. And this is a condition for parallelism. If two lines are cut by a transversal such that each pair of alternate interior angles is equal, if this condition is satisfied, then we can say that the lines are parallel. So this is a condition for parallelism. Now we have learned that if two parallel lines are cut by a transversal, then each pair of interior angles on the same side of the transversal are supplementary. That is, they add up to 180 degrees. And the converse of this also holds. What the converse say? Well, the converse of this says, if two lines are cut by a transversal such that a pair of interior angles on the same side of the transversal are supplementary, then the lines are parallel. So let us consider these two lines, this line and this line. So we have two lines cut by a transversal. So we intersect them by a transversal such that a pair of interior angles on the same side. So we draw interior angles on the same side are supplementary. So we need to check whether they are supplementary or not. If they are supplementary, then we can say that the lines are parallel. If they are not supplementary, then the lines will not be parallel. Similarly, in this case, we have these two lines. We draw a transversal. This and this form a pair of interior angles on the same side of the transversal. If these two are supplementary, then these two lines will be parallel. If these two are not supplementary, then these two lines will not be parallel. So we need to check for these angles. Now we need to measure it using a protractor. On measuring these angles, it was found that this angle is 85 degree. This angle is 95 degree. This angle is 85 degree. And this angle is 93 degrees. So this is what we have. Now let us add these two. 85 degrees plus 95 degrees gives us 180 degrees. So these two angles are indeed supplementary. Hence we can say that these lines are parallel. 85 degrees plus 93 degrees is equal to 178 degree. So these two angles are not supplementary. Hence these two lines are not parallel. So we see that the lines in this table are parallel, whereas the lines in this table are not parallel. And this is a condition for parallelism. That is, if a pair of interior angles on the same side of the transversal is supplementary, then the lines are parallel. So this is a condition for parallelism. So we have studied three conditions for parallelism. What are they? If two lines are cut by a transversal such that a pair of corresponding angles is equal, then the lines are parallel. Or a pair of alternate interior angles is equal, then the lines are parallel. Or a pair of interior angles on the same side are supplementary, then the lines are parallel. So if any of these conditions is satisfied, we can say that the lines are parallel. These three are the converse of the relationships among the angles which we have studied for the parallel lines. Now we have these two parallel lines. They are cut by a transversal. So these 8 angles are formed. So we have 1, 2, 3, 4, 5, 6, 7, 8 angles formed. Now observe that this red angle and this red angle, they are corresponding angles. And we know that in parallel lines, the corresponding angles are equal. So these two red angles are equal. Also, this angle and this angle form a pair of alternate interior angles. and pair of alternate interior angles are equal. So again these two are also equal. Now this and this form a pair of alternate exterior angles which are equal. So this is equal to this. So we see that all the red angles, they are equal. So all four red angles are equal. Now, if we consider these blue angles, this and this are corresponding angles, so they are equal. This and this are alternate interior angles, hence equal. This and this are alternate exterior angles, so they are equal. So all four blue angles are also equal. So we see that although we have 8 angles, but there are only 2 measures. All the red angles have 1 measure and all the blue angles have 1 measure. More interestingly, if you see that this red angle and this blue angle, they are supplementary. So if you know that red angles, the measure of each red angle is x, you can find out that the measure of blue angles is 180 degrees minus x. So knowing the measure of any one angle gives us the measure of all the 8 angles. And this is a very important and interesting property of parallel lines. So although there are 8 angles, but knowing the measure of any one angle, you can find the measure of all the angles. So now can you find the measure of x? Well, we see that these two lines are parallel. This is a transversal. Now this x degree and 115 degree, consider these two angles. We see that these are not corresponding angles. We see that these are not alternate interior angles. Neither are the interior angles on the same side of the transversal. Then how do we find the measure of x? Well, if we consider this angle, then 115 degree and this angle are supplementary because they lie on the same line. So this angle is 180 degrees minus 115 degrees, which is equal to 65 degrees. And now this and this are corresponding angles. So we can say that x degrees is equal to 65 degrees. So the measure of x is equal to 65. So x is equal to 65. Now we have these 3 lines, line L, line M and line N. It is given that line L is parallel to line M. So this line is parallel to this line. Also N is parallel to M. So N is parallel to M. So this is what is given to us. Now let us see what we can get from this. So L parallel to M. When two lines are parallel, then their corresponding angles are equal. So if I call this angle 1 and this is angle 2, then these are the corresponding angles of L and M. So I can say that angle 1 is equal to angle 2. Now N is parallel to M. So again their corresponding angles will be equal. What is the angle corresponding to this on M? This angle. Let me call this as 3. So since N and M are parallel, we can say angle 2 is equal to angle 3. From these two, we have 1 equal to 2 and 2 equal to 3. this means that angle 1 is equal to angle 3. That is, this angle is equal to this angle. But these are the corresponding angles of L and N. These are the corresponding angles of L and N. And we know that if corresponding angles are equal, then the lines are parallel. So we can say that L is parallel to N. So L parallel to M and N parallel to M implies that L is parallel to N. Or we can say that if two lines are parallel to a third line, so L and N parallel to a third line M, then the two lines are themselves parallel. That is, these two are themselves parallel. And it has been proved using conditions for parallelism.